Let's take a look at another fourth order homogeneous linear differential equation with constant coefficients. So let's start by writing the characteristic equation. That would be r to the fourth plus 12r squared plus 36 equals 0. Since technically this is not a derivative, you can also call it a zero order derivative. We will not have a power of r, or power of r is 0. Again, we can solve this by factoring. This is a perfect square, so we'll have r squared plus 6 squared equals 0. This square on the outside indicates that our solutions will be multiplicity 2. And let's find these solutions. We get r squared plus 6 equals 0. So r squared equals negative 6, and r equals plus or minus square root of negative 6, or r equals plus or minus I square root of negative 6. So we have an imaginary number, and you can write it as 0 plus or minus I square root of 6, which means that the real part of that imaginary number is 0, and the imaginary part is square root of 6. Remember that both of these solutions are multiplicity 2. And now we can write the general solution. We get y equals, since we have imaginary number, first we have e to power 0x multiplied by c1 cosine square root of 6 times x plus c sub 2 sine square root of 6 times x. Make sure that x is not under the radical. Close parenthesis, plus e to power 0x multiplied by x, since this was multiplicity 2, times c sub 3 cosine square root of 6 times x plus c sub 4 sine square root of 6 times x. Now let's simplify the exponential functions. E to power 0 is equal to 1, so we don't have to write it down, and we get c sub 1 cosine square root of 6 times x plus c sub 2 sine square root of 6 times x plus c sub 3x cosine square root of 6 times x plus c sub 4x sine square root of 6 times x. And that is the general solution.